Hello students, welcome to your favorite PW Gulf. I am Tanya and yes, today we are going to have the ultimate recap of your chapter, the human eye and the colorful world. So all of you, this is the second chapter of your physics, right? We are going to complete the whole chapter in a very easy and crisp format. So all of you take out a paper and pencil and let's start with the first topic for the day. Have a look, the human eye. Yes, this chapter is divided into two parts, okay? First part, the human eye. The other one, the whole colorful world, scattering, atmospheric refraction, all the things will come here. So let's start with the first thing, that will be the human eye. Okay, so let's start with it. Talking about human eye, everyone, yes, one of the most fascinating organ that we have. Moreover, this organ will enable you to see the things around you with the help of light. Yeah, if eyes are not here, certainly you are going to say that okay, without eyes, of course, the things to visualize that we actually tend to, right, they become very, very difficult for us. Okay, so when we talk about human eye, it is nothing but a camera that is going to capture the things around you. Okay, so I can say, okay, human eye is nothing but a camera. Yeah, using for capturing. Right? Moreover, yes, the human eye, it is going to help us to perceive the distance. Moreover, the object is in a 3D format, color as well, and yes, what exactly about the depth of an object. Okay, so when we talk about human eye, yes, it interprets size, shape, color and distance of the object. How much far away the thing is from me, what is the color, what is the shape. Right, now when we talk about human eye, certainly a camera forming an image there onto the retina, eye will not work on its own. Yes, eye is connected with our brain through optic nerve. Certainly brain and eye, they are working hand in hand. Yeah, so you can say that okay, eyes are not working on their own, not functioning on their own. Brain is also used for the perception, for the interpretation of your object. Okay, now when we talk about eye, right, I believe you all have seen that skeleton, right? Yeah, they're in a biology lab. So when we talk about eye, no, so when we talk about the skull, certainly, so over there you can see that there are two hollow shaped cavities. Yeah, those two hollow shaped cavities are nothing but, or sockets are nothing but orbit. Okay, so yes, those orbits, right, they're very, very important, that okay, there only the eye will be seated. Yeah, so when we talk about the eyes are seated in a hollow cavity, there inside our human skull, we are going to call it as orbit. Talking about the size of an eye. Yeah, so the eyeball has a diameter of about 2.3 centimeter. Okay, now enough of the outer things, enough of about eye, right? Let us look on the eye inside the eye, moreover in a better manner. Okay, so let's have a look. So everyone, I know the diagram of eye tend to be very, very difficult and daunting for us. Okay, now let me tell you, one question will always come in your exam regarding that, okay, draw the diagram of human eye. Okay, and tell me about the part. So you can say that okay, in your exam, in your midterm, in your board exam, certainly in your school exam, UT, you will find one question regarding the diagram, moreover the parts of the human eye, and of course, if the teacher is more curious, she will be or he will be asking about the function of a particular part. So yes, this topic is very, very important. You will find a question on this topic. Okay, so let's start with the first thing, that is nothing but sclerotic, or you can certainly say sclera. Some of the kids, they will get confused. What is sclerotic? This is the new term. Yeah, sclera, same thing. So, okay, sclera is nothing but the outermost coating of the eyeball. It is a tough, white, yeah, you can also see, right? So there is a one dark and the colored portion of your eye, and the other one is the white one. Yeah, the white portion is nothing but sclera or sclerotic. Yeah, so over here, yes, it is white portion of the eye. Now, what it will do, it is going to protect our eye from the shock or any other injury. Yeah, so what is the function of sclera? It is nothing but the white portion of the eye, the outermost portion of the eye, and it is going to protect my eye from any of the outside shock or injury. Okay, moving ahead, have a look on the first transparent projected part, the bulge out part of the eyeball. Yeah, have a look on cornea. Everyone, cornea is the transparent front projected part of the eyeball. Very, very thin, transparent. Moreover, what is the function of cornea? Lot of kids, they actually get confused at what is the function of cornea. Kids, the function of cornea is nothing but to refract the light. What do you mean by that? When light will enter my eye, the first encounter of the light, yeah, as it is doing it with my eyeball, no? So the first encounter, who will do? Cornea. 95% of the refraction will take place here only. Okay, so you can say maximum refraction of the light will be done here in the cornea. Okay, the bulge portion here. Yeah, now the light will enter. Okay, so got the function of your cornea? Yes, maximum of the refraction will be done there in the cornea itself. Right? Now, as the light is moving inside, okay, moving inside, what will happen? So, right now I'm talking about the major parts, right? Of course, I will be talking about the rest of the other, no, not that much important parts as well. Okay, so now as the light is entering, yes, the light will enter and there will be a color diaphragm. Have a look. You all probably would have seen, no, blue color eye, green color eye. Yeah, moreover, some of the people, they also have those hazel eyes, brown eyes. So everyone, yes, this color, how this color we are getting, this is because of iris only. It is the color diaphragm between cornea and the lens. Have a look, cornea and the lens. Okay, color diaphragm between cornea and the lens. Yeah. Now, you know kids that, okay, we say that, okay, I'm having a black color eye. But you know, black color eyes are very, very rare. You will feel that, okay, no ma'am, my eye is black color, it is not of some other color, right? Yes, certainly over there you are just getting confused. Why so? Because we say that, okay, it is black color, no? When you are going to have a look on it very, very carefully, you will see it is dark brown. Yeah, black color eyes, they are very, very rare. Okay, similar to your hazel and the blue and the grays. Okay, yes, maximum of the people, they have dark brown eyes or brown eyes. Okay, now come back over here. So yes, the iris is the part. Yes, what it will do. Now the functioning of the iris. No, what it is actually doing. It is nothing but a gate. Okay, so what type of gate? What? But how gate? Yeah, this term I'm using. No, gate. So everyone, what is the purpose of a gate, right? It will allow the people to enter or to get out. Yeah, similar way in my eye, what is entering? Light. So yes, iris is the gate for my light to enter. It will allow the light to enter and it will allow certainly the light to enter in a specific manner. So what it is doing, it is controlling the amount of light entering. Controller. If certainly you are going to say that, okay, iris is there controlling the amount of light like a gate or like a window. Yeah, window is closed or half window is closed, less amount of light can enter. The bigger window is closed and both the planks are open, right? So yes, lot of light can enter. Similar thing iris is doing. Yeah, as iris is controlling the amount of light entering, certainly the center circular portion, have a look, the center circular portion of my iris through which light will enter, I will call it as pupil and it is dark in color. Black you can certainly say. Okay, so what will actually happen? Have a look over here. Let me draw the diagram also. So the frontal portion, no? Okay, iris and that's the pupil. Yeah, so everyone, when I will say that, okay, iris is controlling the amount of light entering the eye, you can certainly say that, okay, if there is some contraction taking place. Yeah, so how the contraction can take place? Of course, no, iris can actually become more in the size. Yeah, contraction and expanding. Okay, similar way expanding also I'll talk about. So everyone, what is happening here? So if you are there in a very, very bright room, what will happen? Yeah, you are going to say, okay, lot of light is there. I don't require that much light to enter my eye. So what will iris do? Of course, the iris is going to change its shape, control the amount, and the pupil size will decrease. Okay, so over here, the pupil size is actually decreasing. Yeah, why? When the pupil size will decrease, only the specific amount of light will enter our eye and you will be able to see the things around you clearly. Yeah, but when you are there in a dim lighted room, so over there light is less and you require light to enter your eye so that you can form the image, yeah, and interpret the thing. So over there what will happen? Yes, the pupil size is going to increase. As the pupil size is increasing, over here who is doing that? Pupil is not alone doing that. Iris is increasing the size of the pupil. Yeah, as iris will increase the size of the pupil, of course you can say expansion and contraction, the terms over here relatively you can use. So, yeah, have a look. Okay. So in dim light, yes, the pupil size is going to increase so that maximum light rays can enter and image can be formed and you can interpret the things. Similar way, in a very, very bright room, you don't require that much light to enter your eye. So what will happen? The pupil size is going to decrease. Okay, so when we talk about pupil, everyone, certainly, yes, it can contract in excess light. Yeah, and expand in dim light. It can do that. Who is doing that? Iris, the controller is doing that. Okay, contract and expand. Clear, everyone? Yeah, now as we are through with iris and pupil, of course, we are going to talk about some more things. The important things only. Okay, so yes, I'm talking about the most important terms with the definition, and yes, I will give the whole and soul of it as well. Okay, now let's move inside. Okay, let's move more inside. So, after my pupil and iris, certainly I can see a jelly shaped thing. What is it? That's nothing but the lens. Everyone, eye lens. Now, you all also comment there in the chat that what type of lens this is. It is nothing but a convex lens. And convex lenses, they are our converging lenses. They are going to converge the light. Where? On the retina that we are going to talk about. Okay, so my eye lens is nothing but a transparent lens. Yeah, transparent lens. What will happen over here? Yes, refraction will take place over here. So, my light rays are actually converged on the retina. Retina is nothing but the screen. Okay, a jelly shaped transparent lens. Now you can say why we don't have a stone lens. No, why we don't have any solid. Yeah, why here we are talking about a jelly sort of consistency. So we are talking about a jelly sort of consistency, everyone. Why so? Because every time you are not going to look on the object that is closer to you or far away from you. Yes, the objects are at different distances from you. So yes, your lens will change. It can become thin. It can become thick also. Who is going to do that? And here, to answer this question, yes, ciliary muscles are going to do that. Ciliary muscles, they are nothing but the muscles, okay? They are going to hold the lens in the position. Moreover, they are going to control that, okay, you want to see anything far off, you want to see anything that is nearby. So yes, I will control the shape of the lens. By controlling the shape of the lens, certainly they are controlling the focal length of the lens. Okay, by far I believe you all are aware about the focal length. Yeah, so they are going to control the focal length of the lens. How? Yeah, what is the process? Everything we are going to talk about. Okay, so lens and ciliary muscles, they are clear to everyone. Yeah, now let's move. And let's talk about the last two terms, that is nothing but your retina and optic nerve. So everyone, when we talk about retina, simple a screen. On this screen only the image will be formed. right? When you talk about the retina, no, you will see that okay, on the retina there are a lot of light sensitive cells also, sensitive cells also. We are going to talk about them, yeah, and what is their purpose. But basically retina is nothing but a screen on which image is formed. Moreover, retina is behind the eye lens. You can certainly say it is the back part of the eye, yeah, and the eye lens focuses the image on retina. Okay, now when you will clearly look on the retina, no, you are going to see that okay, there is a tiny depression, yeah, you call it as macula, okay, or fovea centralis. Why we have this macula or depression there on the retina? So that we can see the object pretty much clearly and carefully, okay, with clear instinct, right? Now the last thing we are going to talk about, have a look, optic nerve. I use this term, no, optic nerve. So everyone, our eye is connected to the brain, right? How? Via optic nerve. So optic nerve, first of all, here the retina is attached to the optic nerve. Optic nerve carries the image formed on the retina to the brain, but my brain only understands electrical signals, so of course in the form of electrical signals only. Okay, and the place and the particular place where my optic nerve is connecting my eyeball, I will call this as blind spot. Why blind spot? Because over here no light sensitive cells are there. Although the image will be formed over there, you won't be able to interpret it. Okay, clear with this? Basic. Yeah, now let us have a look on the sensitive cells I was talking about. So everyone, when we talk about the light sensitive cells on the retina, two types. Okay, rods and cones. Simple, rods and cones. Yeah, now from the term only you will understand rods, cones. No, why rods and why cones? Because of the shape. Okay, so when we talk about rods, they are rod shaped. Okay, cones, they are cone shaped, present on the retina. Okay, what is the purpose of rod? So everyone, rods are the most important for the vision, but in dim light, or as during the night you can say. So when you are able to see the things in the dim light, yes, it is because of rods. Yeah, cones are there on the retina. Yes, they are sensitive to bright light, and most importantly they are responsible for the color vision. You can certainly say, like, you know, RGB, right? So red color, they are 60%, blue color 30%, green color 10%. Yes, this is the consistency of it. Yeah, RGB you can also see over here. Yeah, rods are these white ones and RGB cones to interpret color. Basic. Yeah, rods are for dim light and cones are for bright light, moreover especially for color. Now as we are through with this, we have some basic understanding of eye, no? So we can talk about eye in a better manner. Now everyone, this is the basic diagram. I know, pretty much daunting, no? So yes, I will give quick view on everything, right? So you will see that okay, there are some things that I haven't talked about. I've talked about most important terms, moreover the functioning of the most important terms for the exam point of view. Okay, now let me give you a quick brief. Now let's talk about sclera first. We know sclera is the white portion of the eye. Moreover, it will help us in order to protect our eye from any shock or external injury. Then we talk about cornea. Cornea is the front bulging of our eye. Maximum refraction will take place here in the cornea itself. Then we talk about choroid. Everyone, choroid is the layer having all the blood cells over here in order to nourish your eye. Okay, similar way, when you will talk about iris, it is the color diaphragm, the controller of the light. Okay, how much light will enter my eye? The controller. Yeah, then when we move ahead, that okay, there is a pupil, the black portion, yes, it is going to contract or expand. How? When you are there in the dim light or you are there in the bright light. Okay, moving inside, yes, you can see your lens, a convex lens. Why convex? So that the light rays can converge. Moreover, yes, I am not able to see anything that is far off. I am not able to see anything that is nearby. My suspensory ligament and everyone, suspensory ligament and ciliary muscles, of course, they work hand in hand. Yeah, both of them. So don't get confused that, okay, what are these suspensory ligaments or ciliary muscles? Yes. Okay, they work hand in hand. Yeah, what they will do, they are going to change the focal length of the eye lens. Right? Then moving ahead, what you have? Your retina. Retina is the screen where your light rays are going to meet and image will be formed. Now, optic nerve, everyone. Your image is taken to the brain in the form of signals by who? Optic nerve. Talking about everyone, blind spot, my optic nerve will connect the retina on this particular spot, and even if image is getting formed, you won't be able to interpret it. Okay, now fovea centralis, macula. Everyone, macula is the depression on the retina. You want to see anything very, very clearly, and macula is responsible for it. Okay, similar way, when we talk about vitreous humor and aqueous humor, everyone, aqueous humor is nothing but a liquid present here between your lens and cornea, you can say, or iris or cornea, you can certainly say. Yeah, it is going to protect my eye from the atmospheric pressure so that my eye is not collapsing. All of you, atmospheric pressure tend to change, no, when you are there on the land and there above the land. Yeah, so yes, it is going to protect us from the change in the atmospheric pressure. Okay, vitreous humor, it is going to protect your eye to maintain its shape, spherical shape. Yeah, a liquid present there in the retina and between the retina and the eye lens. Okay, clear with these portions, everyone? Yeah, the whole eye diagram, of course, you can use the diagram of this as well. Maintaining the shape, I will mention here. Although it is not there in your syllabus and the questions won't come for fovea centralis, blind spot, yeah, very rare. But yet, I gave you a small view on it. Okay, now as we are through with human eye and the diagram, let's have a look on the working. Of course, anatomy is done, no? So what about the working? So everyone have a look here. Yeah, my eye is trying to look a tree. Light rays are coming. Cornea refracting maximum, then of course reaching lens, of course refraction and converging the rays on the retina. Okay, have a look here on the bottom rays, again similar scenario, refraction, again refraction, converging on the retina. Can you notice one thing? Yes, over here you can see that the image forming on the retina is inverted. Moreover, as image is forming on a screen, everyone, image will be real. But when you are going to have a look on the tree, you will say, okay, it's straight. So all of you, I will state something over here. Don't take this in a wrong manner. Just to give a small scenario. Yeah, we tend to believe that, okay, we are seeing through our eyes. Over here, yes, you are seeing through your eyes, but the interpretation is done via our brain. So, you are looking on an object, but you are perceiving it straight. How it is done? It is done by your brain only. Yes, your brain is going to work over here and you are going to see the image straight. You won't say it is an inverted tree. Yeah, so you have to be very careful that when you talk about the working of the human eye, of course, the image from on the retina is real and inverted in nature. But when you are going to talk about the image, of course, it will be straight. How? Because my brain is working over here. The brain plays a vital role. That is why we say, and you can certainly say, you are not only seeing through your eyes, but you are seeing through your eyes and brain. Because of course, brain will help you to interpret the thing in a better and correct manner. Okay, now clear with the working? Yeah, and how you have to proceed ahead. Now, as we are through with this portion, of course, we are going to talk on this question. Everyone, a lot of times, right, I actually get this question and I also get confused that why do we need two eyes? Why cannot I work with only one eye? Yeah, we are going to experience this right now. So keep one hand there onto your one eye and try to experience the world. Yeah, of course you are able to see the things, right? But yes, half vision is actually getting blocked. Similar way to the other eye also. Okay. Yeah. So first thing can be, when I'm keeping my hand on my one eye, lesser view I am getting. Yeah. So everyone, let me clear this whole concept to you. The first thing is perfect, of course. My two eyes are going to provide me a wider view. Wide view. So your one eye can actually give you a view of like 150-degree, right? And the other eye can give you another 150-degree. Moreover, both the eyes, they give you the whole view of 80-degree. Yeah, certainly here in this condition, when we talk about the wider view, of course your two eyes are going to provide you a wider view, and comfortable you tend to become. But of course there are people, they have only one eye, so yes, they are working with one eye and they are getting the view of like 150 to 155-degree. Yeah, that is the view they are getting. Moreover, for the wider view and the clarity and movement of people from left to right, yes, two eyes are very, very important. Okay, second thing will be that when we talk about depth or the closeness of any object, everyone keep one hand of onto your eye, right, and try to observe one object. So over here again, then do it with the left eye. Yeah, you are going to see that, okay, when you are keeping the hands, so the position of the object is pretty much deviating, right? Your two eyes, they give us a better positioning view or the position view. So yes, my both the eyes, they are going to give me the information about the object and its position in a better manner. Yeah, so with the wide view, of course, the positioning effect or the position effect, yeah, that matters a lot. You can try this. Okay, the third one will be, I was talking about the depth, no? Yeah, have a look onto an object, and I believe you probably would have seen that okay, when you're going to keep an object in front of you and keep your one hand onto your one eye and try to look on the object. Yes, it's boundary tend to dissociate a bit. Yeah, you are not getting the proper clarity of the depth of the object. So when we talk about the depth of the object, or okay, the 3D view as such, right? So the two eyes are very, very important. Okay, now we are going to say that okay, there are people, yeah, okay, they don't feel any such of a depth effect or the position variance, right? Kids, after a point of time, no, they have become habitual. Moreover, you are also going to become habitual. Yeah, so yes, from I would say after 1 year or 2 years, certainly with the practice as well. So yes, you are going to adapt. That is why they have adapted it, and they are pretty much comfortable. But yes, it tend to become very difficult when you do it like in a fraction of second or two. Yeah, so that is why our two eyes are very, very important, everyone. Alright, now we are going to talk about something called as your accommodation of an eye or power of accommodation. Now everyone, talking about power of accommodation, no? Why? So as I told you that every time I'm not having a look on the object that is closer to me, far away to me, or at a particular distance, yeah, the distance of the objects, they vary, and I tend to look at the objects that are closer, far away, at a particular distance. So how this is happening? Who is doing it? The process is called as accommodation. It is nothing but changing the focal length of the eye. Yeah, or be specific, changing the focal length of the eye lens. So how you can change the focal length of the eye lens? Yes, my eye lens is a jelly, no? Sort of a jelly, right, structure, right? So you can either squeeze it, make it thin, or you can either, make it thick. So by changing my lens, by either relaxing it or contracting it, you can either make it thin or make it thick, and by that the focal length of the eye lens will change. Okay, yes, it varies from scenario to scenario. Every time you are not going to make it thin, every time you are not going to make it thick. Yeah, let's have a look on the first scenario over here. So, before going on to that, everyone kindly mention that, okay, how the focal length will change, right? Exactly the answer. You know, it is nothing but ciliary muscle. Okay, we have studied about that. So, now let's start with the first scenario. I want to see an object that is far away, or let me say at infinity. Yeah, so the light rays are coming from infinity. Okay, as the light rays are coming from infinity, what will happen? Of course, the light rays are going to reach my eye lens. Yeah, if this is a thin eye lens, right? If my eye lens is in the normal scenario, you know what will happen? Yeah, see over here, my convergence is taking place, but the convergence is not that much stronger, right? Or you can certainly say over here convergence will arise, but yes, the rays are not going to meet that retina. So, I need to make the eye lens thinner. Why so? If I will make the eye lens thinner, no, its focal length is going to increase. As its focal length is going to increase, yeah, my rays are going to meet at the retina. Okay, I know it is a bit difficult to understand, but I'll explain the whole scenario yet again. Okay, similar way when anything is kept near to you, no, so you are able to see the thing properly. Yeah, how so? Because yes, your eye lens is becoming thicker. As eye lens is becoming thicker, my focal length is becoming shorter. As focal length is becoming shorter, of course the rays are going to meet at retina only. Okay, now to understand this thing in a better scenario, let me show you something, and then you will get a better understanding. See, let us take up a scenario. Okay, so these are the two terms that you will hear and you would require: far point and near point. Okay, so with this only I'll make you understand. Okay, and certainly you'll get the understanding of it. So everyone, when we talk about far point, no, yeah, we say that okay, far point is nothing but a particular place where we can actually see comfortably. Okay, so the far point of an eye will be infinity. Yeah, near point, till far away, how much a normal eye can see? Normal eye. Talking about near point, so yes, we are talking about normal eye only. Near point is okay, till what distance I can see properly, clearly. Yeah, so near point will be 25 centimeter. Clear with the basic thing? Yeah, now talking about a normal eye. This is my normal eye. And it is going to converge the rays on the retina. Right, normal eye. Now, let us take up a scenario where the object is far. If the object is far, so you can say the light rays, right? Although the light rays are going to come, right, in a converging format, yeah, but here, of course, the light rays are coming from infinity, so I'm taking it like this, okay, parallel, they are going to become parallel only. Yeah, as they will reach my eye, okay, the rays are parallel, right? So over here, of course, I will say that okay, similar sort of convergence cannot work. Yeah, a normal. You are getting confused that okay, these are also parallel, here also parallel. Yeah, this I shown a normal eye. You can, okay, I can just clear this up. Yeah, a normal scenario. Okay, let's take up this. Yeah, so we are saying that okay, when the object is far away, my eye lens should be thin. Yeah, just consider that. So my eye lens should be thin. It is not, you know, normal. Here I will make it thin. So it should be like this. So everyone, by making my eye lens thinner, what I am doing, if, have a look here, a normal look, let's say this is the normal focal length. Yeah, if I'm making it thinner, of course, the focal length will tend to increase, right? Yeah, the curvature also will vary, no? Okay, normal scenario, right? Similar way, if I will ask that, okay, I am making the islands thicker, so what will happen? Yes, the curvature will also become smaller, right? This change taking place. Although the retina won't change, the lens is only doing that, but I am talking about the curvature itself. Yeah. So, when we talk about anything that is far away, of course it will converge. Of course it will converge. But it is not going to converge at a point close by. Okay. So, when we talk about far point, the rays are coming, the lens is thinner, you have to increase the focal length so that the rays are converging on the retina itself. Okay. Similar way, when we talk about anything that is nearby, you have to make the islands thicker. Ciliary muscles, they have to make the islands thicker so that, see how the rays are going to come. Very, very near, no? So that the rays are getting converged on retina. This all is done, the accommodation process, the changing of the focal length of the lens, yeah, is only done so that the rays are getting converged on retina and we are able to see the image properly. Okay, so when we talk about far away object, have a look over here. When we talk about anything that is far away, right, ciliary muscles, they are going to relax. They are going to make the islands thinner. Yeah, by making the islands thinner, they are increasing, they are making the focal length more. So, over here in simple format, by making the focal length more, what they are doing? Decreasing the power. Just adding one step. Yeah, that will help us. Moreover, when we talk about nearby objects, so yes, ciliary muscles, they actually contract, make the islands thicker and the rays are going to meet on retina. But here what is happening? The focal length is becoming less. As by making the focal length less, power will increase. That we are going to talk about, but yet here, or you can just focus till focal length only. Don't talk about the power if you are not comfortable. Okay, so power of accommodation is nothing but changing the focal length of the lens. Why so? Because we have to see the objects that are far away and nearby. So we have to modulate with that scenario, and who's going to do that? Ciliary muscles. Okay, now taking this thing near point, far point and everything forward, we are going to have a question. So everyone, the question over here is, islands is a double concave lens, double convex, plano convex and plano concave. So everyone try to answer this one. Very easy. Do share your answer there in the chat itself. Okay, so eye lens is a, of course, convex, double convex. So B is the perfect answer. Okay, let's have a look on the next question. The next question here is, which cells respond to color of light? Color. Yeah, on retina we have some light sensitive cells, right? So, rods, cones, pupil, none of these. Try to answer this one and do share your answer in the chat. So, color is nothing but cone. Okay, color with the cone. RGB also I told you. Yeah, color with the cone. Okay, now let's talk about our defects of human vision. So everyone, when we talk about defects, right, certainly, like I'm wearing spectacles, of course there are a lot of people, those who wear spectacles. Okay, so what happens here? So there are basic 2-3 defects that we are going to talk about. First one is myopia. Now the best way to understand about a defect is taking the thing on you. For example, like I do. See, I am not able to see the things that are far away. Yeah, so I take the things on me that okay, I am not able to see the things that are far away, right? Okay, certainly I am myopic. Myopia is also called as nearsightedness. How come? Everyone, whenever we talk about a defect, no, we never encounter or we never talk about the thing that we cannot do. Yeah, we always talk about a thing that we can do. So, if I talk about myopia over here, of course, I will say that okay, I will not talk about my defect. No, I will say that okay, I am able to see nearby things. No, that is why nearsightedness. Nearsighted, that means I am able to see things that are nearby. Myopic, I am not able to see the things that are far off. Okay, nearsightedness, that is why. Okay, in myopia, you won't be able to see the thing that is far away. You will be able to see thing that is near to you. How? See, have a look. This is a normal eye. Yeah? Okay, convergence taking place, light rays are entering on the retina. But when you will have a look on the diagram of a myopic eye, have a look. The rays are getting converged before retina. So we will not be able to see the thing properly. Yeah, anything that is far away, we are not able to see that. So over here we need to correct it, no? Yeah, of course, I can see the things by wearing a spectacle. So how I am getting the spectacle? Okay, before that, let's talk about myopia. It is a kind of defect in human eye due to which a person can see near objects clearly, but he cannot see the distinct objects clearly. Okay. Now, this happens due to elongation of eyeball, as I said. Yeah, moreover, excessive curvature of cornea, the far point and the near point things, now you have to relate it. Okay, so elongation of the eyeball taking place and excessive curvature of the cornea taking place. Now, everyone, let me show you. This is the eye and the defected eye. Okay? Yeah. So, everyone, here I am not able to see the things that are far away, no? Yeah, that is why here, no? So, if as the rays are parallel, so the rays are meeting just in front of retina. So, if by keeping a concave lens in front of my eye and rays are passing through it, first of all, rays are passing through my concave lens. Everyone, what is a concave lens? Diverging lens, right? What will happen? The rays are parallel. Now the rays are going to be diverged a bit. Now as the rays are diverged, okay, I'm just making it a bit bigger so that you can understand. As the rays are diverged, and when they are going to reach the eye lens, so it is much easier to converge the rays on the retina. Have a look. This is what is actually happening. This is how the correction takes place. That is why concave lens is used in myopia. Okay. So yes, nearsighted, yes, of course, you are going to use a concave lens because these lens, right, they are going to divert the light rays a bit so that the rays can be converged easily by my eye lens. Okay, clear with myopia? For myopia, yes, nearsighted, you will be able to see the things that are nearby, and concave lens for the correction. Why? So I have told you. Okay, taking the thing on hypermetropia. Hypermetropia, everyone. Yeah. Another name, that means far-sighted. So, I will never talk about the thing I cannot do. I will talk about the thing that I can do. Far-sighted. I can see the things that are far away. I cannot see the things that are near to me. So, in this particular scenario, what will happen? We will say hypermetropic or hypermetropia. A person who can see the things that are far away but cannot see the things that are near to him. But actually what is happening? The rays are coming and converging behind retina. Okay, so this means that the rays, they are not converging on the retina, they are converging behind the retina. Yeah, that is why we are not able to see the things. So, why this is happening? This is happening because of shortening of the eyeball. Moreover, decrease in the power of lens or increase in the focal length. Okay, let me show you. And let me show you properly, not with a straight ray diagram. You can draw the straight ray diagrams also for this. Okay, let me show you what actually is happening. Okay, thing is nearby. As a thing is nearby, so the rays are coming like this, everyone. Yeah. Okay, and this is the actual scenario. Yeah, all the way draw a proper diagram. You can follow the NCRT, of course. Go ahead. This is just for the explanation purpose, right? So for this particular scenario, everyone, of course, it becomes very, very difficult not to see the thing. So what we have to do? My rays are converging. Of course, they are converging, but they are not converging on retina. So I need to converge the rays more beforehand. Yeah, convergence is taking place. That only I want, but I want more convergence to take place beforehand. So what I will do? Who will provide me the convergence? Convergence is provided to you by convex lens only. There is no thinking also. So what will happen? You are going to place a convex lens before your eye, and look how the convergence will take place. Yeah, converge more. Okay, now reaching more convergence. Let me draw it properly as well. Converged, and here more convergence. Yeah, I believe you are able to see the difference in the convergence taking place, no, in both the scenarios. See. Okay, so I'm just trying to show you. So now convergence is taking place. Okay, I want that. Now convergence is taking place on retina. So things are clear. Okay, everyone, right? Now there is one more defect, that is astigmatism. It usually arises when people, they're not able to see anything like the mesh sort of scenario, the pattern form. Yeah, so for the correction of that, we require cylindrical lenses. Okay, certainly we are going to have a word on that, but yes, this is the whole sort. And all of you, in exam, one question always comes, that what is myopia, what is hypermetropia? The most important thing, diagram, moreover numerical. So everyone, I'm having a trick for all of you. I will also do a question so that you can check the trick as well. So everyone, let us have a look on the numerical trick for hypermetropia and myopia. Okay, first thing is the same. What is that? First thing, the term given in the question, take it as V. Whatever term, number, you want to talk about number? Just write down number. Take it as V. Always and always. Yeah. Moreover, second point, U and V will always be taken negative. Okay, first point, whatever number is given there, no, in the question, right? They won't mention, right? So over there you have to take it as V. Simply. And U and V will always be taken as negative. Okay, talking about myopia, take U as infinity. Simple? Yeah. Talking about hypermetropia, take U as 25 centimeter. That's it. This is the trick. You can have a look on the trick in the easy manner. By these three things, if you will follow these three things, believe me, you will always get your numerical correct. Yeah, and yes, the question will come like that in this form only. We are going to have a look on the question as well. Okay, so let's have a look on the question. The most important thing, have a look. So everyone, a person with myopic eye cannot see object beyond 1.2 meter distinctly. What should be the type of corrective lens used to restore proper vision? First of all, in this numerical, yeah, over here, just by directly stating that, okay, you know myopic concave. Yeah, will you get the marks? No. So in exam, if they are going to give you a numerical, they are asking something. They want you to find out something. First thing over here, right? And some of the kids, now before going on to the question, some of the kids will think, so ma'am, you have told us about u, v, okay, but what formula? Kids, you're talking about lenses, so lens formula only. Yeah, don't get confused that, okay, which formula should I use in order to solve a numerical? Lens formula, everyone. 1 by v minus 1 by u is equals to 1 by f. Yeah, lenses you are talking about. Okay, now come back here. So given in the question 1.2, take this as v 1.2 meter. Moreover, take u and v negative. Easy. Yeah, take u as infinity. Now you have v, you have u. Can you find out the focal length? Can you find out the power? Of course you can. No, place the values then. Don't wait for me. Okay. Yeah. Now, cancelling out. Focal length will be minus 1.2 meter. Simple. Now here you can see that, okay ma'am, should I convert this into centimeter? When we are going to convert it into centimeter, in the power formula you are going to use 100 by f then. Okay, because power is 1 by focal length. Okay, that too in meter. So 1 by minus 1.2. Right? Take this into fraction. Minus 5 by 6. Keep it here. Okay? Removing decimal, I believe. 2526, right? That's the power. Minus all of you. Come on. This is like a, piece of cake. Minus. So, of course, we are going to use a concave lens. This is how we solve a numerical. And this is the whole process. Then you will write down concave lens. Okay, just by directly stating concave lens, it is not going to give you marks. 3-marker question, 2-marker question. Yes, you have to do the whole process. Yeah, they are expecting you to solve and then show them. Okay, just by stating concave lens, they are going to give you half mark. That's it. Okay, that is why numbers are also given. Okay, everyone, clear till here? Now, as we are done with the human eye, the major portion is done, all of you. Let's start with the other portion, that is the colorful world. So for the colorful world, yes, I will start with this topic, that is refraction through a glass prism. You have done refraction through a glass slab, remember? Yeah, a glass slab is there, parallel side. So yes, refraction will take place twice over here. Moreover, emergent ray will be nothing but parallel to the incident ray, certainly, no? The actual incident ray. Yeah, the lateral displacement. Okay, similar way now we are going to talk about a glass prism. Everyone, a glass prism is nothing. Okay, but when you are going to have a look on a glass prism, no? 5-sided solid. Yeah, a 5-sided solid, moreover with a triangular cross section. So you are going to see that, okay, there are 2 triangular faces and 3 other rectangular faces. Okay, let me draw if like this. Okay, probably. I'm not that much good at drawing, yeah, but yet. Okay, a prism. So what happens over here is, when an incident light, okay, passes through my glass prism, of course refraction will take place, and as refraction will take place, no, I will see one emergent ray coming out after second refraction. Moreover, it is not parallel, but it is bended in a certain form. Okay, have a look. Moreover, you can say towards the base only. Yeah. Now, what are the things that are important when you talk about refraction taking place through a glass prism? So, a ray that is coming, have a look, light ray coming. Yeah, draw normal. Let me make also, so that if you are getting confused, let me show you. Okay. Light ray coming, incident ray. Yeah, first refraction, draw normal. Okay, refraction will take place. Let me draw the refracted ray. Now another surface. So again refraction will take place. Draw the normal. Okay, refraction taking place. From air to glass, from glass to air. So yes, from rarer to denser medium. Yeah, rarer to denser towards the normal. Yeah, from denser to rarer away from the normal. Following that. Okay, now in this particular scenario, when you will see the emergent ray, have a look here. This is the emergent ray. It is making one angle with my normal. So what would that angle be? Angle of emergence. In my refraction through a glass prism, everyone, the first and the foremost thing that is very, very important, what is that? You are taking a monochromatic light over here. What do you mean a monochromatic? Single color. Yeah, either red, green, any. Monochromatic light is passing over here. That is how I am able to see this particular emergent ray coming out. What will happen when white light will pass or when normal light will pass, that I will show. Yeah, over here, yes, the light is bending and bending towards the base. Moreover, here the question that is asked is how much deviation is taking place. What do you mean by deviation? So everyone, when we talk about the deviation, no, deviation is nothing. Have a look. This is my incident ray. If refraction would not have been done, or if refraction would not actually take place, so yes, my light ray would have moved in this path. Yeah, but it is not. So deviation is nothing but how much bending is done. Yeah, so if I want to find out how much bending is done, what should I do? Just take this ray, no, and move it back. Can you see one angle? This much is the deviation, angle of deviation. This much bending has been done. Okay, have a look. Yeah, so over there when we talked about glass prism, we remember that yes, we were concerned with lateral displacement, how much move. Yeah, what is the distance between the emergent ray and the incident ray? Over here, as my two refracting sides, they are at a particular angle, that we say angle here, no? Angle of the prism. Okay, as they are in a particular shape, as they are not parallel. Yeah, so over here bending is taking place and we are concerned with the angle of deviation, how much deviation has happened, how much bending has taken place. Okay, so yes, in your glass prism you are concerned with your angle of deviation, how much bending has arisen. Okay, clear? And always remember that your emergent ray will be just bended towards the base. Emergent ray likes the base, so it will want to move towards it. Yeah, pretty much clear with it. Now as I am saying, it is a monochromatic light used. Just remember it, monochromatic light in the scenario. Okay, so you can say the deviation of the ray on passing through a prism, it depends upon the angle of the prism. Moreover, it depends upon the angle of incidence. So my deviation that is happening, no, it will depend upon two factors, certainly angle of incidence and angle of the prism itself. Yeah, this is the base. Okay, refraction and everything, I believe you are aware of it. Now, when we talk that okay, this is a monochromatic light, what will happen if white light will pass through my glass prism? When white light passes through my glass prism, of course it is going to split into a band of 7 color. I will call this band, altogether this band is called as spectrum. Vibgyor. Okay, moreover, you are going to experience this band of 7 color, no, on a particular screen. Yeah, white light is splitting up. This splitting up phenomena is called as dispersion. Yeah, now you can experience one thing over here. Dispersion is taking place, but the band of 7 colors, no, yeah, they are bending. Moreover, they are bending at different angles. Yeah, bending is not same. Okay, violet at the maximum deviation, maximum bending, then least deviation with the red. Yeah, Vibgyor, you can certainly see a proper pattern. Okay, so how this is taking place, everyone? First of all, white light is a mixture of 7 color, that is why dispersion is taking place, but refraction is happening. No, bending is taking place. No, okay, I understand this thing, but what about this bending? So for this particular case, everyone, I believe you remember my refractive index, certainly it is inversely proportional to the speed of the light. Yeah. Moreover, if I say in class 8th, I believe you remember that when you talk about the scenario, no? So your speed of light, yeah, it is directly proportional to the wavelength. Each color light will have different wavelength. What about the wavelength? See, wavelength when we talk about, oh yes, it is nothing but the distance between the two consecutive crest or two consecutive trough. Yeah, I will show the diagram as well. But right now, when we say that, okay, here my speed of light is depending upon the wavelength, and the wavelength here, if I combine this whole format, is inversely depending upon the refraction. Okay, so one thing you can say that if I tell you the wavelength of violet, yeah, is pretty much less, very less. Wavelength of violet is very less. Okay, everyone, when you see the chart also, you are going to see that okay, it is about like 420, and red it is like 720, I believe, gross. Yeah, so over here you are going to experience that yes, if wavelength is less, speed of light will be less and refraction is more. Have a look, refraction is more, maximum deviation, maximum angular deviation. Okay, so when we use this term, no, okay, deviation taking place, certainly dispersion clear, right? Yeah, so why? The question that, okay, refraction arising, maximum deviation, why? So this is the reason. Everyone, come now, have a look on the wavelengths also. Okay, so when we say that our violet bends the most, bends the maximum, why? So because yes, having less wavelength. Lesser the wavelength, lesser the speed, of course my refractive index more, or certainly refraction more. Maximum bending, that's it. Keep the things simple. Yeah. Moreover, when I talk about the red light over here, yeah, what is happening? Least deviation, no? At the top, right? Maximum wavelength, maximum speed. So what will happen to the refraction? Of course, less. Easy, right? Just remember this concept, and then of course the whole thing will be very easy for you. That is why violet is at the bottom. Yeah, red is at the top. Similar with the rest of the colors, and you can see the difference also. Okay, pretty much easy with the dispersion phenomena. Yeah, so yes, violet bends maximum, whereas red bends minimum. Okay, now as we are through with this particular format and the bending of the light taking place and how this bending usually arises, of course we are going to talk about, yes, your recombination. So everyone, what happened? No, yes, when we talk about recombination in simple format, you probably would have seen this there in your scale also. Okay, so have a look on your plastic scale. You are going to see that, okay, when you are going to look onto a light through your plastic scale, okay, nothing happens, white only. Okay, but when you are going to take your scale, no, and take it on the curved and the bended portion, you can see Vibgyor getting formed over there. Why this is happening? So when we talk about a glass prism, over there also you are going to see dispersion taking place, and violet and red, this band spectrum is getting formed, but it gets recombined. So you can say that your glass slab is nothing but a combination of two prism combined all together. Moreover, you can say that, okay, two parallel sides. Yeah, so what will happen? The rays that are coming, no, it is going to break into a band of constituent colors, but again they are going, yeah, and getting recombined. Okay, so in a simple format, you can take this up like, okay, there are two prisms. Prism 1, dispersing prism. Prism 2 is nothing but the recombination prism. Okay, so what will happen? Prism 1 and prism 2, they are going to work hand in hand and they will act as parallel sides glass slab. Okay, so what will happen? This shows that prism 1 simply disperses the white light into constituent colors and prism 2 will recombine the colors and a white light will be seen. Okay, so what is actually happening? Let me show you. Sir Isaac Newton, no, he was pretty much into this. Yeah, so I believe you have heard of Newton's disk. Right, have a look now. Let me show you. See, when this is like a normal scenario, okay, white light is passing through a glass prism, okay, of course there is dispersion taking place and different color, let me draw, red and violet color rays we experience. Okay, but you will now ask that no, we actually see white color light. What is happening? Have a look. See, this was a single light ray that actually is happening. Yeah, moreover, you have to be very, very specific. Have a look on the sides as well. Yeah, alright. So, when multiple white light, they are actually falling. Okay, you are going to see, okay, dispersion is taking place here. But as the dispersion is taking place over here, so what will happen? Certainly, violet and the other colors, no, they are going to overlap onto each other. That is how white light we experience. Okay, similar form you can say your glass slab is nothing but a combination of two prisms. Yeah, so yes, in one prism dispersion is happening and the other one, of course, recombination is happening. That is why you tend to experience that there is nothing but a white light passing through it. Experience it with the plastic scale. You will be able to see the plastic scale, no? Of course, like this. Yeah, like this it is, and from here side it is bended like it. So, prism and in the center portion glass slab. So, in the center portion you are going to see that, okay, white light, and on the edges where it is like a prism, you can see the vapor getting formed. Okay, everyone, now let's have a look on this beautiful phenomena that we experience in our nature, that is nothing but rainbow formation. So for rainbow formation, everyone, I believe, you know, from I would say from our early childhood times, right, we are very much fascinated that, okay, 7 colors there in the sky, how it is getting formed. For rainbow, all of you require 3 scenarios. First of all, a human eye should be there. Okay. Secondly, a light source should be there. Thirdly, rain should have been done. Moreover, water droplets should be there in the sky and they should be of a specific, diameter. Yeah, they cannot be very, very tiny, very, very big. Very, very big, they are going to fall down there on the earth. And very, very tiny, they are going to get evaporated easily. Okay, so rainbow formation is nothing but a simple 3-step process. Here, where is the prism? First of all, your raindrops will act as the prism. Okay, so my light ray from the sun is entering the raindrop. Over there, what will happen? Yes, the first refraction will take place and white light will break down into a band of 7 colors. So you can say dispersion. Okay, refraction / dispersion. Yeah, now when you say that, okay, the water droplet is coming and entering, have a look over here. Can you see the water droplet here, no? This particular face, right? Yeah, so this particular curved face of the water droplet will act as nothing but a mirror. Yeah, and what it will do, it is going to reflect the rays or reflect the colored light, yeah, back. Okay, so what is happening inside the rain droplet? Your total internal reflection where your rain drops inside surface act as a mirror. Now, again, from the water droplet, the light rays are going to come out, the colored rays are going to come out. Again, refraction take place and the Vibgyor certainly we can experience. Okay, everyone, very simple, basic phenomena. Yeah, For this condition, for this whole scenario as it is taking place there in the sky, only one droplet is not needed. Many. Yeah, only one droplet, the rainbow cannot form. Right? Moreover, if you are going to stand, like you're standing here, sun is here, and you expect that, okay, you are able to see the rainbow. No, that is not possible. Why so? Because the sun's light rays intensity is so much. Okay, so yes, here you have to, even if you have to see the rainbow, certainly the sun should be at the back of you. That is how you are able to see the rainbow pretty much clearly there in the sky. Okay, and the sky will act as a screen over here. Okay everyone, so again having a look on the rainbow formation. So when we talk about rainbow formation everyone, 3-step process: refraction, dispersion, total internal reflection, and the last one will be refraction again. So 2 times refraction is taking place, certainly when the light will enter the rain droplet, and of course when it is going to disperse into a band of 7 color. Yes, the colors are going to hit the inside of the raindrop, that will act as your simple mirror. Moreover, the light rays, the colored rays, they are going to move back and move out of the rain droplet, again refraction taking place. Okay, so a very important question that actually is asked there in the exam as well. Okay, rainbow formation. Yeah, now as we have completed a lot of thing everyone, we are going to talk about this term atmospheric refraction. In 2 words I will complete that. Yeah, refraction. What is refraction? Bending of light. Atmospheric, in atmosphere. All of you, your atmosphere is a constant thing. No, right? Stationary. No, right? Made up of a single gas. No, right? So yes, atmosphere is made up of ample of gases of different densities. So certainly we have some hot gas, some hot air, cold air as well. Moreover, nitrogen, carbon, yeah, oxygen, various gases are there. So of course, in atmosphere also refraction will take place. As in atmosphere also refraction is taking place, that type of refraction is called as atmospheric refraction. Okay, so when refraction of light is caused by atmosphere, layer of gases, have a look, layer. Yeah, you are going to call this as atmospheric refraction. Right? So, we experience atmospheric refraction certainly when we talk about twinkling of the stars. Right? Moreover, when we say that, okay, there is a delayed sunset. Yeah, and also when we experience that, okay, the change in the position of the stars. Okay, so yes, these are the scenarios where we experience atmospheric refraction taking place. Why so? Because of the refracting medium is air here. That is not stationary. Earth is also moving. Of course, the air atmosphere is also moving with it. Yeah, so yes, the densities will vary. And of course, because of that, air layers have different optical densities. So when the light ray pass through the air layers of different optical density, refraction of light will take place in simple form. Have a look how the bending is taking place, no? And everyone, our eyes know, they are pretty much very sorted and very naive, you can say. So what they will think that, okay, if the light is coming in this direction, no, so they are going to retrace the path. They are not going to think that, okay, the light might have been bended, this is not the actual path of the light. They are going to retrace the path in the backward direction and experience and observe that, okay, light is coming from that particular position. Okay, to understand this thing, no, we are going to talk about apparent position of stars. Everyone, when we talk about light coming from a star, luminous body, right? I believe all of you know. Yeah, star, luminous body. Okay, so what will happen? Have a look. Yeah, the moment the light will enter the atmosphere. Okay, so all of you, the air above the Earth's surface, like kilometers, right? It is going to be less denser. And then as you are going to move closer to the Earth's surface, let me say this is Earth, it becomes denser. Yeah, so refraction will take place. So yes, light is coming. Light is coming. Okay, so entering. Rarer to denser towards the normal. Then again, this will be rarer for it and denser towards the normal. Towards the normal. And reaching my eye. Okay, this is my eye. Yeah. So everyone, have a look. The light is bended. But for my eye, you know what will happen? My eye will retrace the last path, this one, and retraces back. So my eye will think that okay, the light is coming from this particular position of the star and the star is at this particular position, not at the actual position the star is. Okay, so this is how, because of the different layers of atmosphere and having different optical density, refraction is taking place, and certainly we say that okay, a star seems to be a bit higher, much higher in the sky than it actually is because of atmospheric refraction only. Okay, twinkling of the star, certainly the earth is not stationary, it is also moving. Moreover, the atmosphere is also moving, so optical densities vary, refraction varies. Because of that, we experience twinkling also. Yeah, at times more refraction, yes, certainly twinkling, it actually occurs. Moreover, you can do it with your hand as well. Yeah, so blocking of the light, right? So at times no light, then light is there. So yeah, so if I say that okay, my hand, okay, have a look on my eye. I won't use my eye because it is not giving out light. Okay, yet if I say keep a torch or a flashlight in front of you, okay, and keep your hand, right, and try to move it like this. So your hand is nothing but varying optical density of the atmosphere and certainly the particles. So when you will see the variance in the light, no, brighter, then dimmer, then brighter, dimmer. This is how lights also twinkle because of atmospheric refraction. Okay, now moving ahead. Let's talk about advanced sunrise and delayed sunset. Everyone, when we talk about advanced sunrise and delayed sunset, no, first of all, have a look over here. This is the observer. Yeah, and this is the horizon. I believe all of you are aware about the horizon, right? When we talk about the sunset, okay, the sun is above the horizon, we are able to see it. Sunrise and sunset, no, below. Sunset will be below. So, what happens is, when sun is nothing but a luminous body again. Luminous, no? And eyes are naive, no? So they are going to believe. Yeah. So what will happen? The sun is going to give out the light. Of course, rays are going to come. So what happens is, as the light rays are coming and entering, they will undergo refraction, bending. Moreover, the last path of the light ray, yeah, when it will reach my eye will think, okay, light is coming from this particular position, and even if the sun is below the horizon, we are going to experience that okay, the sun is above the horizon. Yeah, so yes, this is the apparent position of the sun. So like maximum of like 4 minutes, no, the 2 minute advance and the 2 minute delay, we see 2 minutes extra, before the sunrise. Moreover, we see the sun 2 minutes extra after it has already set. So like in the total of like 4 minutes, we see our sun extra. Okay, the sun is not risen. Yeah, yet you will be able to see the sun. That would be like approx of 2 minutes. And then the sun is actually set. Yet you would be able to see the sun because of atmospheric refraction only. Yeah, and total of 4 minutes. Certainly, this apparent and the actual position of the sun, it collides at 2 p.m. in the afternoon, and then again the same scenario takes place. Okay, so yes, collision also rises, but in the afternoon itself. But I believe till here, clear? Yeah, light rays are coming from the sun, entering the atmosphere, they will undergo refraction, and my eye will think that okay, the light is coming from this particular path, this straight particular path, although the sun is just below the horizon yet. Okay, similar way, the sun will go down the horizon, yet my eye will think that okay, the sun is at this particular place right now. Yeah, so we are going to see the delayed sunset in that particular scenario. Okay, everyone, clear with this topic? Yeah, so now let's talk about the last topic, that is nothing but scattering. Everyone, when we talk about scattering, right, it is nothing but capturing and then re-emitting. Okay, who will do this? This is done by the particles itself. Moreover, it is seen there in the colloidal solution, the particles having a particular, width. Yeah, so what happens in your scattering, everyone? It is simple like distribution. How? Taking the light and then redistributing it all direction. Yeah, so when we talk about scattering, when light falls on tiny particles, yeah, Then diffuse reflection takes place and light spreads in all the possible direction. So what will happen? Let me show you. See, if light is coming, this is my light ray, okay, having a particular wavelength. Okay, now there is a particle in its path. Okay, there is a particle in its path matching the wavelength of the light. So what will happen? This particle is going to absorb this light and redistribute it in all the direction. This is what scattering is. Okay, so when you talk about tiny particles, they are going to absorb the light of shorter wavelength. Similar way, bigger particle, they are going to absorb the light of the bigger wavelength. Yeah, so when we talk about tiny particles, right, and they are going to absorb the light and re-emit it in all the direction, you are going to call it as scattering. Okay, similar way, if I talk about, we are able to see the sky in blue color. And sunset and sunrise, we see the reddish color over there. Yeah, so we see the sky blue color. How so? Because when the light is coming, yeah, from the source or the sun. So yes, Vibgyor, white light is nothing but Vibgyor. So violet, indigo, blue. So violet and indigo, they are having very less wavelength. Yeah, so they are going to get dispersed away easily, scattered away very easily. Talking about blue, no, when the particles are tiny, they are going to capture the blue light and then re-emit it in all the directions. That is why we see blue sky. You can simply say like this. Let me erase it. Simply say it like this. Violet, indigo, blue. Violet, indigo, blue, green, yellow, orange and red. Okay. Yeah, see. What will happen? Violet scattered easily, then indigo, then blue is scattered and green, yellow, orange, red, they are going to move ahead. Blue is scattered away. Yeah, so you are able to see the blue. Okay, then green, yellow, orange, they are going to move ahead. Yeah, here scattering everyone, it will depend on the wavelength. When we talk about scattering, no, let me share. When we talk about scattering, the phenomena, this is the formula, Rayleigh formula. Yeah, or in easy terms, you can understand lambda to the power 4 wavelength. Yeah, so in easy term, you can understand scattering is inversely proportional to wavelength. Okay, more the wavelength, less the scattering. Yeah, lesser the wavelength, more the scattering. That is why we say when we talk about red light, no, yeah, it is pretty much used in danger signals. Why so? Because yes, it is having more wavelength, scattering will be less, so easily movement. Okay, so when we talk about scattering everyone, the path of the beam of light passing through a true solution is not visible. Colloidal solution, particles should be suspended there. True solution, no, sugar solution if you are taking up, not visible. The path of light won't be visible. You require colloidal solution for the particles to be there suspended in the solution so that the light can be captured and re-emitted. Okay, so here where the size of the particle is relatively larger, Rayleigh proved that intensity of the scattered light is inversely proportional to the fourth part of the wavelength. This. Yeah, so smaller. See, scatter is smaller in size than the wavelength. Okay, everyone? Clear with this scenario? Now let us see it. So one effect I believe you probably would have studied in your chemistry also, that is Tyndall effect. What happens is simple. Light beam is there. Okay, you are taking this light beam and passing it through a solution and a colloid. True solution colloid. So here I am taking a water and over there milk and water. So everyone, when have a look on the diagram only, don't see anywhere else. On the diagram, I can see the light beam is visible, the path of the beam is visible there in the colloid. Why so? Because of the particles. As the particles are suspended in the liquid, they are going to capture the light and re-emit it in all the directions so that we can see the path of light. Okay, talking about these particles include smoke, tiny water droplet, suspended particle of dust and molecule as well. Yeah, fog as such, smog. When a beam of light strikes such a fine particle, the path of the beam becomes visible The light reaches us after being reflected and diffused by these particles, scattered by these particles. Okay, this phenomena of scattering of light by a colloid, okay, you're going to call it as Tyndall effect. Okay, so the phenomena where you are concerned that okay, the scattering of light is taking place, but they're in a colloidal particle, certainly Tyndall effect. Okay, now let us experience it. That is, as I told you, the color of the sky is blue. Everyone, when we talk about the color of the sky being blue, have a look in the diagram itself. Yeah, so here the sun's rays are coming there in the space and entering the atmosphere. So what is happening? Your violet is also getting dispersed and blue is getting lot of scattered away. Yeah, as blue is getting lot of scattered away, what is happening to green, yellow, orange, red? They are moving down. Right? So here you are going to see and state that the particles there in the atmosphere, they have smaller size. As the size is smaller, certainly they will scatter the light, but they will scatter the light of smaller wavelength. So smaller the wavelength, scattering will be more. Blue wavelength is smaller, scattering is more. Moreover, red's wavelength is more, scattering is very less. That is why we are able to see the sky as blue. Okay, now talking about the phenomena where we see the sunset and sunrise, reddish and orangish. What happens over there? The light has to move a lot of distance. So in that particular scenario, everyone, yes, scattering is taking place, but now as lot of distance my light has to move, so blue will be scattered away, yellow, green will be scattered away, and the particles also tend to become pretty much heavy and bigger in size. Certainly over there they are going to scatter the red and orange light as such. Okay everyone, so here in this case one thing is very important. What is that? Scattering is taking place, but as scattering is taking place, over there distance, the light has to move a lot of distance. So yes, blue is having a smaller wavelength, it will be scattered very easily and moved away there in the space. So longer wavelength light rays, they are only left out to scatter as such, and they scatter and produce orange and reddish color sky when we talk about sunrise or sunset. Okay, you can have a look on the diagram as well, because the sun, they are pretty much near the horizons. Of course, light has to move a lot of distance. Okay everyone, clear with the whole scattering phenomena? Very easy topic to ponder upon. Yeah, so I believe the things are clear to everyone. Keep on practicing, and yes, note down the important points. All of you, hard work is the key to success, so certainly keep on practicing. Take care everyone. Thank you so much.